Welcome to Virtual Wisdom Finance and Accounting Tutorials. My name is Peter and I'll be your guide in this particular tutorial. Today, I want us to look at how to solve simultaneous equations using matrix algebra. In matrices, if you look at my other tutorials, I have prepared very nice videos on how to work out or how to solve matrices. That is matrix addition, matrix multiplication, subtraction, etc. etc. Now in this particular case, I want us to use the knowledge in matrix algebra to solve simultaneous equations. Simultaneous equations are two equations that you are supposed to solve to find the variables that are given there, or the coefficients. So we have an illustration here that using matrices calculate the values of x and y for the following simultaneous equations. So we have two variables here. We have variable x and we have variable y, or coefficient x and coefficient y, that we are supposed to calculate, that we are supposed to look for using matrices. So how do we go about this? Let's look at a solution. I'm going to discuss, or I'm going to show you how to solve a simultaneous equations using matrix algebra. And in this case, I'm going to illustrate it in several steps. Starting with step number 1. Write the equations in the form of ax plus by equals to c. If you look at the equations that we are given here, these equations are not arranged in the form of ax plus by equals to c. So you have to arrange them. How do you go about that? So to arrange that, you take the 3 because it's a whole number there. Then you're going to remain 2x minus 2y equals to, when this negative 3 comes on the other side, it becomes a positive, so we have plus 3 there. So we have 2x minus 2y equals to 3. Then on the other one, we have 8y equals to 7x plus 2. You can decide to take the 2 on the other side, then bring the y on this side because you're starting with x. So that you have 7x. When you bring 8y on this side, it will be minus 8y. Then you take 2 on the other side, so that will be minus 2. So when you do that, you're going to end up with this equation, 7x minus 8y equals to negative 2. And now that you have the two equations and they are arranged, or they are organized in the order of ax plus by equals to c, now you can move to step 2. And in step 2, I'm going to write the equations in a matrix form. Now, for you to write the equation in a matrix form, you take the coefficients of the variables. Here we have variable, we have x, we have y. So you take the coefficients of x and y to make a matrix. So the coefficient of x here is 2. So you bring the 2 there. Let me show you. So we have a 2, you bring it there. The coefficient of y here is negative 2, you bring it here. That is for the first matrix. And then for the second one, we have the coefficient of x here is 7 and the coefficient of y is negative 8. You bring it there. And then the variables, we have variable x and variable y equals to what we have on this side. So it is equals to 3 and we have a negative 2 there. So at the end of the day, we have a matrix. That is step 2 of that question. We move to step 3. In step 3, you're supposed to find the inverse of the 2 by 2 matrix. 2 by 2 here shows the order of a matrix. And the order, we normally start with the rows multiplied by the columns. I normally have my personal formula that I use. I normally say red card. Red card meaning red, AR, comes first, and then card for C. C follows. So anytime you're dealing with matrices, that is always the order. Whenever you're multiplying, whenever you're adding, anytime you're dealing with matrices, the order should be R followed by C. That is rows followed by columns. So the 2 by 2 here, the first 2 here represent the rows. Then the second 2 represents the the columns. So when you say that a matrix is of order 2 by 2, it simply means that we have two rows. So we have row 1 and we have row 2, right? And then we have two columns. So we have column 1 and we have column 2, and that's why it is a 2 by 2 matrix, a 2 by 2 matrix. So this 2 by 2 matrix is what we have gotten here. This is this is the 2 by 2 matrix here, and that is what I'm carrying to the next side here. Now we need to find the inverse of these matrix. Now for you to be able to find the inverse of that matrix, the first thing you need to know is how to find the determinant of a matrix. For you to be able to find the determinant of a matrix, let's take given a matrix W given by A, B, C, D. This is a 2 by 2 matrix, and these are the elements of matrix W. So to get the determinant of W, you take A multiplied by D, that is A multiplied by D, you minus C multiplied by B, C multiplied by B. That is how you get the determinant. So to get the determinant of our matrix here, you take 7 multiplied by negative 2. Sorry for that. So we have, you start by A multiplied by D, that is 2 multiplied by negative 8. We have it there, minus 7 multiplied by negative 2. 7 multiplied by negative 2. That is going to give you minus 16 minus 14. This return to be a positive, so it is minus 16 plus 14, which is negative 2. So the determinant of our matrix is negative 2. After getting the determinant of that matrix, the other thing that you need to determine is what we call the adjoint, the adjoint of that matrix. Again, given a matrix W, the adjoint of a matrix W given by A minus B, C, D, the adjoint of W will be given by, what you do with this, you interchange these two. So the A here will come where D is, and then D is going to move where A is. That is, in that diagonal, that is what you do. So we have D coming here and we have A coming on this other side. The next thing, you change the signs on this diagonal. So you change the sign of B, it is a negative here, so here it will be a positive. The sign of C, here it is a positive, it will be a negative there. That is how you get the adjoint. So in our matrix, we have matrix 2, negative 2, 7, negative 8. So you interchange. So 8 will go there, and then 2 will come here. So we have negative 8 here, and we have 2 on the other side. Then you change the sign of 7. It is a positive here, so it here will be a negative. Then we have negative 2, it will be a positive 2. And we have the adjoint of our matrix there. After getting the adjoint, now it's time to get the inverse of that matrix. So to get the inverse of a matrix W, where matrix W is what we had here, you take 1 divided by the determinant multiplied by the adjoint. And we said that the determinant of that matrix is given by A, D minus C multiplied by negative minus B. Then you multiply that by the adjoint, and the adjoint we had it here, we had the adjoint there. Then now in our matrix, what will happen? So we are going to have 1 divided by the determinant. We found that the determinant of this matrix is negative 2. So we are going to take 1 divided by negative 2 multiplied by the adjoint of this matrix. The adjoint was that. So we are going to have this is a constant multiplied by a matrix. So you simply multiply each element in this matrix by negative 1 over 2. So that will be negative 1 over 2 times 8. That will give you 4. Negative 1 over 2 times 2 give you negative 1, all the way to give you up to each and every element. And now this is what will be the inverse of our matrix. We have the inverse there. Then after knowing how to get the inverse of that matrix, we now move to step 4. In step 4, you multiply both sides of the matrix equation with the inverse. And the matrix equation that we are talking about here is the first equation that we developed. This is the matrix equation. So in this equation, we need to multiply by the inverse of this matrix then you multiply by the inverse of the matrix on this other side. So there we go. So this is the inverse of the matrix. We multiply by it here, and it is here on the other side. We multiply it there. So for us to know whether it is possible to multiply here, remember the rules of multiplication. Again, red card, rows and columns. For you to be able to multiply, if for example it is a 2 by 2 matrix, the number of columns here must be equal to the number of rows of the second matrix for you to be able to multiply. So maybe something like that. It is possible to multiply that. So these must be able to cancel out with these for you to be able to multiply. So how do you check that? So look at this. This one is a 2 by 2 matrix, and this is a 2 by 2 matrix. This is a 2 by 1. This is a 2 by 2. This is a 2 by 1. Now let's see, these are 2 by 1, this 2 by 1. Now let's see, is it possible to multiply this matrix and this matrix? Yes, you cancel these and these. If it is cancelable, whatever is remaining is a 2 by 2 matrix. So it simply tells you that when I multiply this matrix here and this matrix here, the resulting matrix should be a 2 by 2 matrix, whatever that is remaining here. Then on this other side we have a 2 by 2, 2 by 1. Again, you can cancel this by this. So the resulting matrix here should be a 2 by 1, 2 by 1, which is this 2 here and this 1 here. So 2 by 1 matrix should be the resulting. So how do you go about multiplication? So let's start with this other side. So this will be 4. Remember, you start with the rows followed by the columns. So you start with the first row. So this will be 4 multiplied by 2 plus -1 multiplied by 7. As you can see, it is row versus the column. Then you go to the second one. If you go to the second one, remember it is a row versus that. So if you go to the second one here, it will be 3.5 multiplied by 2. 3.5 multiplied by 2, -1 multiplied by 7. That is what we have here. Then you do the same. If you go to the second column now, this will be 4 multiplied by -2. We have it here, this one here. Then negative plus -1 multiplied by -8, this one here. Then lastly we have this one here. It is 3.5. We have 3.5 by -2, -1 by 8. Then you add the 2 to give you that. So when you complete this, you're going to have an identity matrix. Identity matrix, that is a matrix with the zeros on the major diagonal. So you have 1 0 0 1 is a matrix there, and then this we have xy here. This is the resultant for that. Then you have xy. And then on the other side again, multiply this, open it up. This will be the row versus the column. So it is 4 multiplied by 3 plus -1 multiplied by -2. Then the second one will be 3.5 multiplied by 3 plus -1 multiplied by 2. Then you have it there. So the resulting will be that. So if you want to open this bracket, if you are to multiply these two again, it will be 1 multiplied by x plus 0 multiplied by y. So this one will end up having what? An x. This one will end up being an x plus 0, which is x. Then this will be 0 times x, which is 0, and then you have 1 by y, which is y. Then you have y plus 0, which will still be y. So as you can see, we are remaining with x, we are remaining with y, we are remaining with x, we are remaining with y. Now this will be equal to the what we have. Remember, this is the solution for this. This is a solution here. We have it there up that point. Then equals to 14 12.5. That is what we have here, 14 12.5, and therefore you end up having x equals to 14 and y equals to 12.5, equals to 12.5. And that way you'll have solved the two simultaneous equations using matrices. You're going to get your x as 14 and your y will be 12.5. 5. I hope this tutorial was useful. This was virtual wisdom, finance and accounting tutorials. Kindly do me some favor by subscribing to the Virtual Wisdom Finance and Accounting Tutorials YouTube channel. Click on subscribe here. Let your subscription count. Next time we check, let's not have the same number of 155 subscribers. Let's have more. Kindly visit the website and subscribe to the channel if this video was useful to you. Kindly subscribe. Don't forget to click on the bell icon, that is after subscription, so that you're notified anytime that I upload new videos. Anytime I have new content that is useful to you, you'll get updated whenever you click on the bell icon. Like the videos, share with your friends and leave a comment. If you have a question, you can drop it here. I'll check it and respond to it as soon as possible. Thank you for your time. Thank you once again. Bye.